Hello students, welcome to standard 9 subject mathematics. This is chapter number 14 statistics. This is lecture number 7. In last lecture we have started the graphical representation of the data, and in that we have understood how to draw the bar graphs. The two examples we have seen how to draw the bar graphs. Now the next graph is histogram. In histogram also we have two types of histograms, of uniform width and of the width, varying width. So in this lecture we will see the histogram of uniform width. What is this? Let's understand. The histogram, how to draw, first we will understand. This is a form of representation like the bar graph only, but it is used for continuous class interval. For this, when we use the histogram, when the class intervals are continuous, and when they don't have the continuous data, like in the previous example we were having, it is suggestible to draw the bar graphs. And if the class intervals are continuous, for example we will see, then only we have to draw the histograms. For instance, for example, consider the frequency distribution as follows and draw a histogram. Here as you can see, the weights in kilogram given and the number of students given. The weights in kilogram are 30.5 to 35.5. 9 students are there having this type of weight. 35.5 to 40.5 weights having students 6. 40.5 to 45.5 weights having students are 15. 45.5 to 50.5 weights having students are 3. 50.5 to 55.5 kilogram weights having students are 1. 55.5 to 60.5 kilogram weights having students 2. So here you can see the weights are given in the class interval form, and these class intervals are continuous. You can see at 35.5 and starts with 35, so continuous classes are there. So here the condition comes continuous class intervals. So we will not draw the bar graph for this, we will draw the histogram for this. One more thing you have to note here, that in each of the class size is 5. 30.5 to 35.5, 35.5 to 41. Each of the class size is 5, means gap of 5. So, because its class width is same or class size is same, it is called uniform width. So, this type of graph, how to draw, let's see. So, in solution of this example given, here the class size is, first of all, before drawing the histogram, it is very important that you have to see carefully the class sizes are of equal length or not. So here the class sizes or width of the classes are uniform. Uniform width are there, 5 gaps each of the class has. So we can draw a histogram easily by taking on x-axis the class intervals we have to show. On x-axis these class intervals we have to show. In this case the class intervals are weights in kilogram, that we will show on x-axis, and on y-axis their frequencies, means number of students, we will show on the y-axis. Therefore the histogram of the uniform width, it is uniform width, so it is easily drawn. On x-axis we have shown the weights in kilogram, that is the class intervals of equal length or equal width. And on y-axis we have shown the number of students. As the number of students are minimum 1 and maximum 15, so we have shown like that. So 15 covers on the y-axis. So 2 gap we have taken 1 centimeter equals to 2 students. That way we have managed the graph. In your graph book or your graph page, you may show it all by taking 1 gap only. So it is suggestible to you when you are drawing in a graph paper or in a graph book, you take 1 gap only. Don't take 2 gaps. Then also the whole graph will come in your page. Here 5 gaps are there in the kilogram, that is taken in the 1 centimeter. So about this, always you make the practice of writing the scale also. Whenever the graph you are going to draw on the graph page, suppose this is a graph page of your graph book. So you have to draw this with the x-axis and y-axis, and on this area corner area, right corner area, you have to write the scale of it. Whatever the scale you have taken on x-axis and y-axis, that you have to show. So what we have done on x-axis? On x-axis, the 1 centimeter equals to 5 gaps we have taken, 30 and 35. So 5 gaps, so 5, and its unit is kilogram. So 1 centimeter shows, 1 centimeter gap shows 5 kilogram. On x-axis it is, and now on y-axis, 1 centimeter shows 2 students. 1 centimeter. Each of the 1 centimeter shows 2 students gap I have taken. In your case, when you are drawing on a paper, you can take 1, 2, 3, 4, 5, 6 and 16 will come. No problem with that. So you can take here, when you are taking 1 gap, you will write here 1 student. But if you are taking this way, 1 centimeter as 2 students you are showing, so you have to write 1 centimeter equals to 2 students this way. So always write the scale also when you are drawing the graph if you have changed something there. Now one more thing to notice here in the graph, that this number starts from 30.5 and after that 5 gaps are there, but it is from 0. This value doesn't start with the 0. The classes are not starting with the 0. Directly they are starting from 30.5. Means 0 to 30.5 information is not given here. So when you are going to represent the graph directly from some number which is not 0 actually, like here the example. So to show that directly the 0 to that gap, we have to make the break actually. This way the sign we can make. This type of break we can show. It is called kink also, kink or break we will show. It shows that 0 to 30.5 data comes in between that and nothing, no information about that, so we are just folding it like that. You can show it. So this sign is for directly starting, not starting from the 0 the data is. So this sign we have shown from 0 to 30.5 directly. Now as we were drawing the bar graph, that way the simple way we have to go. But what is the difference in bar graph? The equal spaces between the 2 bars were there. Here we will draw the continue bars, continue rectangles. Bars are in the form of rectangles. So very first bar will be 30.5 to 35.5. This class interval has 9 students. So its height up to 9 we have to show here. So up to 9 we have to go the height of 30.5 to 35.5. So it is from 30.5, the height will be 9. And how to show 9, that you understand now. As you have taken at 8 and 10 between 1 centimeter, so between half of this 8 and 10, the 9 will be there, that you have to understand. So half of this will be here up to this height. Okay, and this height is also the same for the bar. This way the rectangle we will form of 9 height to show the weight of the students. 30.5 to 35.5 kilograms. Students are 9 students. This is the one rectangle we have shown. Second is 35.5 to 40.5. The class has 6 number of students. So this height will be, this gap height will be 6. To show 6 from 40.5 to this way 6 height we can show. Up to 6. This is 35.5 to 40.5, 6 number of students, and 40.5 to 45.5, 15 students. So this gap, this interval height will be 15. So as you can understand, to show 15, We have to show between 14 and 16. So it will be 14 and a half. Right? This one. Between 14 and 15, this is the height of 40.5 to 45.5. The measure from here between the 14 and 16, it will be 15. So this height shows 15 height of 40.5 to 45.5. Then 45.5 to 50.5 has 3 students. So up to 3 the height will be of its rectangle's height is 3. And 3 will be between 2 to 4. This way. Between 2 to 4. This height. Right. Next, 50.5 to 55.5 is one number of students, one only. So this is only one we have to show here. The height will be up to 1 and 1 will be between 0 to 2. So this height must be, so this is the height of 1 we are showing. Then 55.5 to 60.5 kilogram having weights at number of 2 students. So its height must be 2. So its height is 2 now we will show. Up to 2. Here 2 is here. You can see the level, height level is 2. Showing 2 number of students are having the weight of 55.5 to 60.5. So this way the continuous rectangles without gap between we have drawn, and this is actually the histogram of uniform width. You can see here also you can give the shade to the your graph, shading this way with the pencil and scale, so it will look better way. You can show, you can draw the shapes. So this is the histogram of this given example of continuous class intervals where we have, and as well as the width is uniform. So very simply we can draw the histogram as we are drawing the bar graph. Similarly we have to go, but don't leave the space between the two rectangles because no option will be there because it is continuous data. So we have to show the bars this way only. And these all bars are all here, the rectangle. Here one thing we have to note that the area of rectangle is directly proportional to the frequency. In this case of histogram, what is the case here? What is the, to understand here? The area of rectangle area of each rectangle is proportional to its frequency. That we have to know. So that also you will note down. Area of each of the rectangle are proportional to corresponding frequency. Right? Areas of rectangle are proportional to its corresponding frequency. That must be noted here in histogram. So this way, in this lecture we have seen the histogram of uniform width. In next lecture we will see the same histogram but in non-uniform width. When the width are not same, when the class sizes are not same, how to draw histogram, that we will see in the next lecture.